Hello students, welcome to today's object-oriented software engineering class. In this session, we will study on use case modeling, which is another important technique used during system requirements phase of software development. Use case modeling is a technique used to capture the functional requirements of a software system from user's perspective. The major steps involved are identifying the system boundary, finding the actors, finding the use cases by specifying each and every use case, and creating scenarios. These steps help developers to understand exactly what the users expect from the system. A use case model consists of four major components. The first is an actor. Actors represent a person, an organization, or a system interacting with the software. This is represented by using a stickman icon. Next is use case, which represents a function or service provided by the system. This is represented using oval shape within which the name of the use case is specified. The third is relationship, which shows how actors and use cases are connected. This is represented by a line starting from the actor and pointing towards a corresponding use case. And finally, system boundary defines what is inside the system and what lies outside it. So this is represented by a rectangle covering all the use cases of the corresponding system. The first step in developing a use case diagram is identifying the system boundary. We decide which functionalities belong to the software and which functionalities are outside to the software. Next, we define actors. An actor represents a role rather than a specific person. One individual may play multiple roles depending on the application. To identify the actors, we ask the questions such as who uses the system, who installs or maintains it, which external systems communicates with it, are there any time-based events that trigger system activities. Remember students, even time can be an actor. For automated missions, you can specify time as a separate actor. Answering these questions helps us to identify all the users and external entities interacting with the system. Once the actors are identified, the next step is to determine the use cases. A use case represents a service that an actor expects from the system. Every use case is initiated by an actor and is always described from actor's point of view. While identifying use cases, we ask the questions such as what functionalities does the actor need? Does the system store or retrieve information? Does the system notify users when events occur? Each use case should have a short and meaningful verb phrase as its name, such as login, register student, or generate report. In this example, you can see a complete use case diagram where there are three actors, namely customer, shipping company, and dispatcher. Each and every actors will have corresponding use cases. For example, place order, cancel order, shipping product, etc. And a relationship line connecting from the actors to the corresponding use cases. In this example, customer can place an order and a shipping company and a dispatcher can ship the product. Finally, a rectangle box covering all the use cases together. After identifying the use cases, each one is documented using use case specification. Use case specification is represented by using various fields. It starts with the name of the use case. In this example, pay value added tax is the name of the use case. It starts with use case ID, which is a unique number to represent the use case, followed by the actors who are all getting involved in the particular use case. Next three important parts are precondition, flow of events, and postcondition. Preconditions mention what must be true before the use case begins. Flow of events says the sequence of interactions between the actor and the system. And postcondition describes the system state after successful completion of this particular use case. For example, in an ATM system, having a proper valid ATM card with password might be the precondition. Flow of actions include inserting the ATM cards or swiping it, inserting the PIN, and validating the credentials. Postconditions will be either successful login or unsuccessful login. To ensure that every requirement is addressed, software engineer performs requirement tracing using requirement traceability matrix. A matrix like this will be framed where Each and every row represents the requirements and each and every column represents the use cases. There will be a mark mentioning each and every use case addresses corresponding requirements. For example, if there is no mark in a line, then we can clearly understand that the requirement is not addressed yet. A scenario is one possible path through a use case. Every use case contains exactly one primary scenario and multiple secondary scenarios. The primary scenario represents the normal flow where everything works as expected. In addition, the secondary scenario represents the alternate paths or exceptions, errors or interruptions. While identifying secondary scenarios, software engineers carefully examine each step of the primary scenario and look for possible alternate conditions and exceptional situations. These scenarios make a software system more reliable by considering both normal and exceptional user interactions. Use case modeling is most suitable when software systems are driven by functional requirements, involve multiple types of use cases, or supports many external interfaces. However, it is less suitable when the system is mainly concerned on non-functional requirements or has any other fewer users and limited interactions. From a placement perspective, use case modeling is again the most frequently asked UML topics in software engineering interviews. Interviewers may ask you to identify actors, draw a use case diagram for the given application such as ATM, library management, etc., and explain the difference between actors, use cases, scenarios, and system boundaries. Mastering this topic will help you in your mini project, final year project, software documentation, and system design interviews. To summarize, in today's class, we have introduced the concepts of use case modeling, including actors, use cases, system boundaries, and use case specifications, requirement tracking, and scenarios. The concepts provide the foundation for developing UML diagrams and accurately capture the user requirements. Thank you all and see you in the next class.